P of x is true where x is a, or rather I should not write P of x is true. I should write P of x where x is a variable of type t. Okay. So P of x is a statement involving the variable x, and here I am stating the type of the variable. So this is the general structure of statements involving variable. But from this, two distinct types of situations can arise. And that I will obtain when I write like this. You look at this. Okay, now I am going to write two statements involving this equation. X plus 1 is equal to 1 for all real numbers x. This is one statement. Another one is x plus 1 is equal to 2. I said equal to 1. That is wrong. For at least one real number x. Look at these two statements. Okay. X plus 1 is equal to 2 for all real numbers x. X plus 1 equal to 2 for at least one real number x. Definitely these two statements are somewhat different because of this change of phrase, for all, for at least one. Now what is happening here? First of all, we see whether these are valid statements because now they involve variable. Have we stated the type of the variable? Yes, we have. X has to be a real number. That is fine. But look at this. For all and for at least one. These are called quantifiers. What they do, they quantify the variable x, or they quantify the situation where the statement, that is how much is the statement true. That's what they quantify. Here the first statement is claiming that this equation is true for all real numbers x. So real numbers is the type. So x can take any real number value. So the first statement is rather strong in the sense that it is claiming that this equation is true for all real numbers x. No matter what value of x we put here, we are going to get that plus 1 equal to 2. Obviously this is false. This cannot be the case. So the first statement is false. However, what about the second one? It says that among all real numbers, there is at least one real number for which this is true. And this turns out to be true. And that real number is x is equal to 1. So this is the least, this is one extreme, this is the other extreme. This needs at least one value of the variable for which something is true. This needs this to be true for all values of the variable. So these phrases, for all and for at least one, instead of for at least one, you can also write for some. Okay, these are called quantifiers. They quantify the situation. How much is something true? Because now we have variables, so we can think of for how many values of the variable our statement is true. Previously we did not have to do this because we dealt with only constants. Okay, but now we have variables, so we can do this. So these are called quantifiers. This for all is called universal quantifier. And universal because it says that the universe from which X is coming, for everything in that universe, this is true. Okay, that's what it says. And this is called, you may have guessed, existential quantifier. For all is universal quantifier, and for at least one or for some is existential quantifier. Okay, now there are symbols like many things, or almost all things in logic. We have come across these symbols: wage, v, then negation, implies, if and only if. There are symbols to denote these quantifiers. So we can, instead of writing these, we can write like this also, using symbols. For all is written like this.